this is question 16. So what does it say? Question 16 says evaluate this. Okay, so evaluate 81 to the power 3 over 4 like this. So how do we go about it? So when you're given an index or a power that's a fraction, you write it in this way. Take your number, put brackets, okay, then put this, and then here the denominator of the fraction comes here. The numerator goes there. The numerator becomes the power. Another way to think of it is if somebody asks you 3 to the power 3, what they're actually saying is 2 to the power 3 over 1. But then we take this one as the power just because it's the numerator. Here it's also the same thing. But then we take this power, this thing as a power, and we take this thing as a power just because it's numerator, and then this one should be the root, and it's the denominator for that case. So the fourth root of 81, you should know it's 3. 3 by 3, that's 9, by 3, that's 27, by 3, then you get 81. Okay, so this one would be 3, and then you just use brackets just in case. This one wasn't tricky, but then, you know, sometimes it gets tricky, so you want to be safe always. And the way that you are safe is to just be in the habit of using brackets. And this is it, you get 27, and you're done. If you want, you can pause it because I need to erase this. Let's move to question B. So question B says 9 to the power x minus 1 multiplied by 3 to the power 3x minus 2 equal to 3. So 3 would be 3 to the power 1 here. So whenever you're given these and it's paper 1, usually what it means is that all the entries, they can be expressed you know, using the same base. So here, for example, 9 would be 3 to the power 2. But then if it's 3 to the power 2, you should know that it's multiplying this or that, okay? Don't forget, it's not 3 to the power 2x minus 1. It's 3 to the power 2, open bracket, x minus 1, just like this. That was the tricky part. 3 power 1, then here you get 3 to the power 2x minus 2 multiplied by 3 to the power 3x minus 2, just like this, equal to 3 to the power 1. Then you get 3 to the power 2x minus 2. Here you can add this if you want. Okay, so 3x minus 2, that's equal to 3 to the power 1. If you have the bases, they're the same, you just add the powers when these two are multiplying. Okay, so what do you get here? You get 3 to the power 2x minus 2 plus 3x minus 2 like this, equal to 3 to the power 1. So you get 3 to the power 5x minus 4 equal to 3 to the power 1 here. And why did I write this one here? I don't even know, yeah, but then this was opposite. So here you get, if your bases are the same, that means also the powers, they're the same. So 5x minus 4 equal to 1, so that means 5x equal to 1 plus 4. That means 5x equal to 5. Then you divide both sides by 5, of course, then you get x equal to 1. And some of the stuff you can actually prove it yourself. So for example, if you put 1 here, you'd get 9 to the power 1 minus 1, which is basically 1. Then here you put 1, so you get 3 to the power negative 2. So here you get 9 to the power 0 times 3 to the power 1. So you get 1 times 3, which is equal to 3, which is equal to right hand side. Okay, so some of this stuff you can prove it, but then you when you're revising, that's when you check this. For now, don't work out something then revise. You just work through everything, then afterwards you create some time, then you revise. Let's quickly move to question 17. So question 17 says, given that y is inversely proportional to this, and this is whether you're given the conditions. And this you should be familiar with it. Whenever they give you proportion, so here you should be able to interpret this. Inversely proportionate means 1 by. So in this case it'd be this squared. You're given this so that you can find your constant k. So you get y equal to k over x minus 1 squared, like this. So when you get rid of the proportionate sign, you introduce a constant. That's the etiquette. And then you can substitute this. So you can say when y equal to 2, x equal to 7. Okay, then you just write this. Then you have 2 equal to k by 7 minus 1 squared. Okay, so I have 2 equal to k by 6 squared here. So k equal to 2 by 6 squared, multiplying both sides by 6 squared here. So which is equal to 2 times 36, which is equal to 72 here. So yeah, this is, you should, if you want, don't underline this. Okay, this is not really your answer. Your answer would be, let me write it in different color. Your answer would be y equal to, you go back here, then you replace. Okay, you replace the value of k. So the value of k for our case was, we found out it's 72. So y equal to 72 over x minus 1 squared, like this. And then this would be your answer. And then you're done. So just remember this answer, because I have to wrap this. If you didn't get it, then just pause the video. So yeah, I'm not going to wrap the answer because we will need it. So here, I want to use a very interesting method. So just take note. I want to use a very interesting method here. Calculate the value of x when y equal to 8. So when y equal to 8. So if you want, you can repeat your relation first. Then y equal to 8 here. So 8 equal to 72 divided by x minus 1 squared. So you can multiply both sides by x minus 1 squared. X minus 1 squared. Here we're doing this so that we can clear the fractions. So you get 8x minus 1 squared equal to, those ones they cancel obviously, so you get 72. So you can divide both sides by 8 again, you get x minus 1 squared equal to, this would be 9. So you get x minus 1 squared minus 9 equal to 0. Okay, so this is difference of two squares. I don't know if you noticed. So you get this, and this is difference of two squares. Just use big brackets. So x minus 1 here, that's the first square root, square root of the first square rather. Then x minus 1. Then here square root is difference of two squares in the sense that there is negative here. So plus 3 minus 3. Okay, instead of expanding this whole thing and then trying to find factors, this is what you could do. This is equal to 0. Okay, so here you get x minus 1 plus, get plus 2. Okay, here you get x minus 1 minus, you get minus 4 equal to 0. So that means x plus 2 equal to 0, or x minus 4 equal to 0. That means x is equal to negative 2 or 4. Done. Okay, this is done. That's it. So let's quickly move to question 18. Question 18 says a luxury coach leaves Blawayo for Harai every morning at 7:30 a.m. and arrives in Harai at 1 p.m. Express the departure time as a time in 24-hour notation. So the departure time means when the bus leaves. So it's 7:30 a.m. This one, it's the 12-hour notation, this one. So 24-hour notation, it'd be 0, 7, don't forget the colon, okay, so 07:30. So when it's in the morning, when it's in the afternoon, you just add 12 there. So when it's 1 p.m., then it becomes like 13. You will see, in the next step. So in the next step, we are told to calculate the total time taken to travel from Blawayo to Harare. So we need to subtract departure, arrival time minus departure time. But then arrival time, so 1:00 p.m. minus 7:30 a.m. Okay, which is equal to, this one would be 1300. Write it in 24-hour notation. If you want, you can put hours here and minutes. So here 1300, and then this one would be, we calculated to be 07:30. Okay, so we need to subtract those. So here 0 minus 30 you can't So one way to look at it is that when you're working out the minutes, you're working out in base 60. So this is base 60. So 0 minus 30 you can't, but then you can add 60 here, which is one set. If you add 60 here, you have to increment here by 1. Okay, it's like you're in base 60 for the minutes. So here you get 30. So 60 minus 30, you get 30. Then this minus 8, you get what? You get 5, I think. Is it? Yeah, 5. So you can even not put this semicolon. So it'd be 5 hours, 30 minutes. Okay. So this is it. So here, remember when you're subtracting the minutes, you can think of it as you're working out in base 60. This one would be working out in base 24. Yeah, but then it's a more complicated way to look at it. So just make sure you add 60 minutes here. When you add 60 minutes here, increment this one by 1 hour so that they're in balance. And then you're good. Okay. So we calculated 5 hours, 30 minutes, just remember it. And now we're supposed to calculate the average speed. Okay, so the average speed, let's say V equal to, we're given the distance here. Just read it through. Calculate the average speed of the bus nearest whole number if the distance from Blawa to Ara is this. And remember the buzzword here is nearest whole number and also average speed. So average speed is equal to, you can even write total distance divided by total time taken. So total time taken would be 5.5 hours like this. So here you would get, if you want, you can even multiply by 10 both sides, on top and at the bottom. So you get this. Here you get 55. This one would be kilometers per hour, of course. So 5, it's definitely a factor. So here, 5, you get 11. 5, you get 8 here, I think. And the 2, then 5, you get 5 here, I think. And the 4, then here you get 8, I think. Then 11 into 85. So 11 into 85. I'm just trying out things here. So 11 into 85, you get 7, as in 77. So you get 7 here. Remember what? Remember 8. So 11 into 88, what do you get? 8. So you get 78 kilometers per hour. Okay. If you had like a remainder or something like that after this, then you'd have to just write it to one decimal place, and then you'd see how that first decimal place would affect your answer, so that you can round up or down. So that's it. Let's quickly move to question 19. Question 19 says factorize completely, and what do we have? We have CG minus DG minus CH plus DH. Whenever you have 4 entries, usually it almost certainly means just match the brackets. Okay, so here for the first one, it's okay, just do whatever you want. So but then you just factor out what's common. So whatever you want, in the sense that you can factor out negative G, it would still be okay. But then for the second bracket now, you have to factor out such that your bracket is the same as this first bracket here. So here it would be wise for me to factor out negative H. Why? Because I'll be left with C here inside minus D. Again, so minus and plus, you get minus. Again, the idea here is to match these brackets. Okay. After matching these brackets, you take that bracket separately, and then you get this one into this one, you get G. This one into this one, you get negative H. So it's just combining these coefficients here, and then you're done. Okay. So let's quickly move to question B. Question B it wasn't very hard. Okay, it wasn't as hard as it looks. So normally when we evaluate this is paper 1, so they normally give you stuff that you can factorize. So they're determining there it's a specific number. It's not irrational. It's a specific number. So here you have this, and normally you would say 5 times -4. That would be your those would be your that would be your product. So 5 and 4. But then you need to create negative here. So if you have 5 and 4, you need to create negative. You just have to. And you can also play around with this, but then playing around would have not helped you. You want this to be as close as possible, which the way that you're given, it's already as close as possible. So here you just have to determine what sign to give, which should be negative to this big number, such that -4 plus 5, you can always get -1. So go there and then replace -5d plus 4d minus 4. This is easy as well to see, because if you don't get the factors right, then you won't be able to factorize. So d minus 1 here. So you get 5d plus 4. Same scenario as we had previously. So here, this, and then you're done. You have factorized it, okay? You're done now. And let's move to question 20. So here, you normally say 5 times 4, then you get 20. Then you have to find factors of 20, 2 factors of 20, such that you multiply and get -20, and you add, and then you get negative here. So I was just saying 4 and 5, they're given already. But then we just have to figure out which one do we give -2, such that we get this -1. So that's what we did. So let's quickly move to question 20. Question 20 says the pie chart shows the distribution of an athlete's daily exercise program. Okay, so calculate the value of x. So here, this is a pie chart, and then a pie chart, all the entries there go to 360. So it would be x here plus 150 plus 75 plus 2x. Okay, so this and this and this, they should be equal to 360, like this. So here you get 3x equal to 360 minus 150 minus 75. Okay, and here I want to show you something as well. You can evaluate here, but then it's still okay. What you realize is that 3 is a factor through and through. So you can just divide each and every entry by 3 here. That's one way to do it for those who love math. So here it should be divided by 3. Here it would be divided by 3, then you get 25 here. So you actually get, this one would be 70, I think. So 70 minus 25, what do you get? You get 45. So x would be equal to 45 degrees, just like this. And then you're done. So you've calculated the value of x. If you want, you can just work out this one. I think you get 110 here, and then you subtract 75, then you still get 45, still okay. Just wanted to show you a different way to go about it. So x is equal to 45 here, don't forget. I'm just going to wrap this. If you didn't get it, just pause your video and just look at it before proceeding. So B1, what does it require? The time the athlete spent on weightlifting. So we're given now, if the athlete spent 18 minutes jogging, so jogging, which means 45 degrees. So 45 degrees is to 18 minutes, okay? So we asked to find the time spent on weightlifting. So weightlifting would be 150. 150 degrees would be equal to simple proportion, it'd be more. So if it's more, bigger number at the top. So 150 divided by 45 degrees multiplied by 18, like this. Then if you want, you can say 15 into 45 here, you get 3. 15 into here, you get 10. Okay. Then 3 into 3 here, you get 1. 3 into the here, you get 6. It'd be 60. 60 what? Minutes. This one was supposed to be 18 minutes here. So 60 minutes. That would be your answer here. So the time spent on the weightlifting would be 60 minutes. And then the time spent on the total time spent exercising. You can use the simple proportion, but then here it'd be total time would be corresponding to the share would be 360 degrees, like this. So if it's 360, it's still again more. So it's 360 degrees divided by 45 degrees multiplied by 810. Okay, so if it's like this, then we can say 15. Okay, let's try 15. 15 into this, you get 3. Then 15 into this, you get 2 minus 6. And 15 into this, you get 4. Then here you can say 3 into 3, you get 1. 3 into this, you get 6. So 6 by 24. So 24 by 6. Yeah, I just want to show you the interesting stuff. So this 24, this is 24 by 6. Okay, so you get 120 here. Then plus 24 here, so you get 144. So it'd be 144 minutes. So which is equal to 144 minutes. Okay. So 144 minutes would be the time spent on jogging. So that's it for now. We'll finish the rest of the questions in the next video. So remember to like, share, and subscribe. And if you have any specific paper that you want us to cover, would be really willing to do that. And you can just leave a comment in the comment section below. And also we deliver like topic by topic tutorials, but then those ones we deliver on our website, primaEd.com. So it's something to check out. So for now, cheers. Yeba out.